Okay, so following on from the theory that we were discussing before, I'm going to talk about the actual physical, way that we will perform this retopology, right? So I'm just going to make sure my screencast keys are on here. Okay, so we've got our high poly here. This will be some sort of character or a weapon or a prop or anything, something like that. But we're going to focus on the human faces and some of the major topological landmarks that we need to achieve that, right? You don't have to draw these lines on like this, but I'm going to leave them here just as a reference for you so you can sort of see theoretically how I'm trying to work in this topology to meet these lines, right? What I'm going to do is I'm going to add a new mesh, okay? And I'm going to call this, actually I won't call this anything. I'm going to move it into a collection called low, right? And I guess I already had a collection here. I'm going to leave the old one in the collection called high. So we've got the low and we've got the high, right? Now I'm going to call my major high poly object David underscore high. And now I'm going to call the low poly object David underscore low. And I'm going to double check to make sure that, all their transforms and scales and blah, blah, blah are all zeroed out, right? So the next thing I want to do is I want to give the low poly some sort of a material, right? And now that I have the material assigned, I'm just going to call it something like low. It doesn't really matter what we call it, but what I'm going to do is go down to the viewport display, and I'm going to make this object some variety of like lime green, just some very obvious color, right? Now I'm going to move the plane up and just sort of get it on one side, kind of over here, right? Okay. Now I'm going to talk about the display of this object a little bit. So in Blender, we now have, if I go up to multi-mesh overlay, mesh edit mode overlays, I can tick or untick this retopologization shading thing. I'll turn that on in a little bit, but I'm going to explain sort of why we need it, I guess. Okay, so I'm in edit mode, I've got a plane. I'm going to turn on snapping up here so that every command I do is going to snap to the face, right? But instead of just using face up here, we're actually going to say snap target for individual elements, face project. So what that means is that whatever I currently have selected, the individual elements, right, the verts, the minute that I move this with a grab command, see how it's snapped immediately to the surface? If I left click, it's now going to place those verts all on the surface of David, right? Now, as I move them, as I scale them and move them, they're going to keep re-snapping. So see how if I do this at a weird angle like that vert there is going to move down and snap to his nose. So you've got to be a little careful with how you move these, right? But you can see that the object isn't really visible, right? If I just start sort of extruding like this, the object isn't like really visible at all, right? Because it's sitting upon the surface of the face, right? Something that we can do to overcome this is by adding a shrink wrap modifier and saying, I want you to sit above the surface of David with, say, 3 millimeters of offset. Okay. Now, we're going to go back to that retopologization shading method and use that instead, but I just want to introduce this because this is kind of like a lo-fi way of doing it, right? Just the lime green material with a shrink wrap with a little bit of offset, right? But you can sort of see the key point here, right? We have a low poly object, which has not many polygons. And if I flag this button on shrink wrap, I'll be able to actually see the verts themselves, right? We have these polygons themselves, which are lower detail than the high poly underneath it, which means by definition, there's going to be some sort of surface discrepancy. Our normal map is going to capture that surface discrepancy and render it back as shading. So the user, if you do a good enough job, won't really be able to tell the difference. They will if they're close, like really paying attention, but in general, not really, right? So that's kind of the goal here. We want to wrap this surface with a mesh that represents the high poly like as close as possible and minimizes discrepancy while also using as few triangles as we need, right? So maybe on this piece here, on this large piece here, we would say, well, that's too much discrepancy. So we will add another loop cut there with Control R and clicking, and that's going to like give us enough geometry to smooth this out. But we wouldn't want to do something like this, right? It's way too much geometry to actually represent this shape, right? Yes, it like conforms very well and is above the surface, but that is just way too much geometry, and it's just, you know, that's not what we're here to do, right? We're here to actually reduce the geometry of the high poly, right? Okay, so using shrink wrap is you know, kind of okay, but Blender now has a different method up here with this shading retopology tick. If I tick this, it's going to give us like, it's going to essentially do what shrink wrap was doing, but in a shader driven approach. And it lets us actually specify, hey, I want, say, 6 millimeters of artificial depth to like be rendered over. So if I pan my camera at a very extreme angle, we can see like the discrepancy. But looking flat on, if that distance is less than say 6 millimeters, which I typed in up here, then we're not gonna see the underlying high poly mesh. The reason I still do, like even with this view mode, is that I still use the bright lime green one and I still use the shrink wrap modifier, is that when I'm sculpting, because we can swap into our sculpt mode as well and use a grab brush to move these around gently, and that's going to show the lime green thing, and it's going to keep the vert slightly above the surface. Not far, but just a little bit. So I actually still use both, right? So I'll use like just an obnoxious colored material with a very bright viewport display, a shrink wrap modifier, and then when I'm in edit mode, I use the retopology shading with, you know, some very small distance, I guess, that shows us roughly the discrepancy, but doesn't completely obscure it, right? So that's the basic setup to this, right? So again, we want our snapping on, we want face project flagged, right? And we want to set up our object either through shading or a material in some way where we can just see the mesh that we're working on, because we need to be able to see the thing to actually work on it, right? In advanced, like more advanced topology, there are dedicated tools to do a lot of this, right? In particular, we now have polybuild in Blender. I'm not going to be using polybuild at all because, you know, it's a little bit, I don't know, in my eyes, it's a little bit more advanced. I want to teach you the very simple stuff, and then later we'll go into like more advanced techniques. So I'm just going to roll with the basics, right? So I'm going to start with the eye loop, right? Because this one to me is just is super easy to comprehend, right? So I'm just going to extrude across, rotate and scale, and put that roughly there. And my goal with this one is just to create an entire enclosing loop. Doesn't need to be perfect, right? Something like this. And because we're snapping to the surface, we can move and reconfigure this, and it's just going to like hang around on the surface of the high poly. Okay? So there's this loop here. Give me 1 second, sorry. Okay, cool. So there's that loop there. Right, this is that green one that we've said. And if we need more detail, like if the discrepancy is too large, like here it is, we can always insert with a control loop and then move that geometry around a bit, right? Okay, so, but I'm going to get rid of that for now. I'm going to keep this a little bit loose, okay? We now want, like the visor loop, right? So we want to basically say, and I'm just going to do this temporarily on a second loop, but we won't end up doing it that way. We basically want to say from the center of the face here, we want another loop running along, okay? Like this. Now you may have noticed that we've actually got some back face flipping here. The reason that we've got that is because I basically took a single edge off of this, and it's Blender's just going to make like an edge doesn't have a normal. So when I do this extrusion, it's just going to take a guess as to which way it faces. And if I extrude to the right, it's going to face backwards. If I extrude to the left, it's going to face that way. That's totally fine. What we would typically do is just grab that and flip the normals, right? And then from here, we would continue. So you just, if you're going to be copying and pasting edges around like that, you just kind of have to pay attention, right? So basically the visor, we want to come around like this, right? But I actually don't want these loops to be split like this, because I know from my diagram that they actually need to be connected, right? We've said this loop is contained within this loop, you know, which is sort of contained in this loop. So I'm actually going to start by grabbing existing edges on the eye and extruding that off, right? And then from here, I'm going to continue around matching the edge count of the underlying structure, like this, right? And then I'm just going to select one and the other and bridge across, right? There are some hotkeys to do that a little bit more efficiently, right? If I instead create this kind of a structure, I'll just do this real quick, sorry. center. Okay, I can now select this last face and tap F, and Blender's going to be smart enough to say, well, there's a loop there, there's a loop here. I'm just going to naturally continue that around, right? By spamming F over and over again, right? Makes sense, right? But, you know, whether or not you want to use that's up to you. For now, I like to work sort of loop to loop, so we'll just leave that as it is, right? I guess. We also want to continue these all the way to the middle of the face. So I'm just going to extrude all the way over and then Control R, click a couple times. Sorry, mouse wheel up a couple times and then left click to add like a cut back in there, right? Now we said on our diagram, if I actually turn on, I was pretty inconsistent with it wherever I drew the poles. Okay, there. We'll just focus on the rev for now. We said that we would have two poles here, here and here, one up here, one up here, and one here, right? Going back to our planning, the reason is anytime our loops diverge, we get a pole. This blue one is diverging this way. The green eye loop is running like this, so we expect a pole roughly about here and roughly about here, right? Now the pole is going to be formed because this loop that we are creating, like this, will get to about here, right? This blue loop. And I'm just going to recalculate outside, make sure all my normals are in line. It's going to get to about here. But then this blue loop wants to continue like this. So by definition, it has to split off, right? Now we know that there's only two poles in this region. There's no other poles in this region. So therefore, our hand is naturally forced from here. We basically want to do this, right? Followed by this, followed by, you know, that, and then this. Do you see? And don't actually make the geometry like this. I'm just sort of communicating what we need to do, right? It's going to go that way, and that way. It has to, because we're not going to insert any extra poles into this region, right? So I'll block in this other pole here firstly, right? That one's going to go up here. That's going to make this a pole, and this is going to be our pole. From here, we largely just have to take these edges to the center line, right? So I'm actually going to do that by grabbing these and extruding these up like this, and then I'm going to insert an edge loop here, click to confirm it, double click, sorry, to place it there, and then I'm going to bridge this back here to here, like that. Now, this is where a lot of like beginners might get a little bit, I guess, like confused. How do we marry all this up, right? This one kind of makes sense, but then what do we do here? Oh no, this is an n-gon, what are we supposed to do? Do we add a loop here and then collapse this down like this? No, because we've said that there's going to be two poles here, right? Let me just undo that real quick. So all we need to do is we insert another loop cut on the top side, and that just naturally lets us merge from this one to this one, and this one to this one. We know that there's only going to be two poles here, because we know that there's going to be one loop here that diverges in two places from the underlying eyeball structure, right? So that's what we're going to do. We have two poles here, bang and bang. Then all you really want to do is just like move this topology around a little bit. And it's okay for this to not be as detailed as it needs, because later we can use things like subdivision modifiers to like increase the detail automatically. So what I'm actually trying to do is just roughly get the polygons in roughly to the scale that I know that they need to be. And you'll learn that sort of scale just like naturally over time, right? So we have two of the key loops in, right? We have the eye and the visor, right? And I'm just, because this is asymmetric, I'm only going to model one side of it, but ideally you would be working on symmetric models, right? But for this study, we're just using this one. I'm now going to block in this one, right? This loop here coming all the way down. It basically goes from up the cheek all the way down to this little top side of the lip. And then I'm going to add some extra loops just to kind of support that, right? Cool. That one's pretty straightforward. Following along with the eye, I'm going to do the mouth now. And we know that the mouth is going to, it's going to have to essentially do kind of like this, right? Whoops. Kind of like that. But we already have edges in this region now, right? So we can start from here now. We can extrude this over, put this in the middle, and then run, say, a loop cut here to just give us a little bit of extra geometry like that, right? And I'm just going to continue this around naturally. And that's why, like, the edge flow it becomes really important, because it becomes super easy just to add a control loop and place another one here, right? So edge flow benefits us in the modeling stage, not just the deformation and topology animation stage, right? we did establish that we're going to have a pole here, right? Because this loop diverges this way and this loop diverges down here. So we leave this here as our pole, right? It's like on the natural boundary of both of these sort of loops. And then we need to create a quad here that's going to continue up this way, right? So now we're just going to fill in this area. And what I'm doing is I know that there's going to be no poles in this region. So I'm just matching edge count for edge count. Here to here, here to here, here to here, so on and so forth, right? Okay. Now, we also know that there's going to be no poles in this sort of purple region. This is just going to be one continuous loop that kind of goes like this, right? All the way around without any poles. So we know that this is going to need to match the edge count of everything surrounding it. It's going to just need to naturally kind of match in. So that means all of this here is going to be a part of this loop. Really, it's going to do this, right? So I'm going to just grab all of these. I'm going to grab to here. I'm not going to grab to here because if I grab to here and extrude down, that's going to create a pole here. So I'm going to leave that like air gapped there, and I'm just going to extrude all of these down. And then I'm going to just massage roughly where it needs to be, right? And the point of this one is the laugh line. So we want to make sure that the placement of our edge is going to intersect like the laugh line, right? Now, a lot of people might sort of like merge like this, but I actually don't want to do it that way. I don't want to do it that way because that would place sort of this pole a tad high. The point of that pole in my mind is to, you know, function sort of, I guess, like interfacing with the bottom of it's really hard to describe, isn't it, I suppose? But I'll show you what I mean to say, right? I'll put a subdivision here, and I'll bridge that. And then I will add just a touch more geometry here for the mouth loop. Like this. And now instead of having one face here, I'll continue that like that, right? And then I'll bring this over here. Oops, sorry. Like that, right? And even in my attempt to communicate this to you, I still put the pole in the wrong direction. I don't really want the pole to line up with this pole. I want it to be offset one more. So I'm going to try and fix this again, right? I'm going to add a loop cut here, and then I'm going to merge these ones, right? Because the pole is formed when we open up the difference between the loops. So I can sort of shift the pole over by scaling these verts to nothing, and then merging these together. You could also do, you know, merge, collapse at center. Okay, so I've now shifted the pole from this vert over one to here. This is really where I want the pole, right? Cool. I'm going to leave the nose there for now. Should have a little bit more geometry there. Awesome. Cool. So that's kind of the way I like to think about it. The way that I sort of see it is like, don't line this pole up with this one. They should be sort of offset by a little bit. This allows us as well to like route extra nose geometry. Like if you look at this loop here, we can route sort of like extra nose geometry into and around like the nose itself, like, you know, into and around underneath the nose, that sort of thing. Sorry, give me 1 second. Cool. So let's get to finishing this like larger loop here, right? So we know that there's going to be no poles. So we wouldn't make anything like this, right? Because that would give us like a 5-pointed pole here, right? Even if this was a quad, we wouldn't exactly want that here because we know sort of ahead of time we're not going to have a pole in this region. So that sort of forces us to collapse this so that the edge count between this outer loop and this inner loop is the same. And then we just continue expanding around like this, right? Now the purple loop is actually very large, like quite large, right? It's going to cover a lot of the face, sort of like that, you know? This loop as well is sort of a part of the purple loop, right? This and this are sort of the same loop, I guess. And I'll show you what I mean. I'm going to just continue this loop, this one here, all the way around, exactly matching the purple one that we established here. Easy way to do that, you know, just sort of extrude these out and then bridge these back, bridge this back, right? If I get rid of this inner loop here, you can see that this is the structure we're making. It's actually a very large, like singular loop that kind of goes all the way around, right, to the chin. But we typically won't remove the inner line. We'll keep that there because removing it would impart like way too much discrepancy between the high and the low. And we have a fair amount of that here, but we're going to start like sort of slowly correcting bits of this, right? And we can sort of massage geometry in as we need it, right? So we're talking about discrepancy just there. I'm going to add another loop cut here, which is going to just give us like a bit more geometry to kind of hold that edge with, right? Something like this. And that's what the power of like the good topology really is, right? If I want more geometry here to smooth out this discrepancy, I can just I can just literally divide it in like that, you know? And because like the snapping tools, it's just going to naturally match the underlying surface, something like that, right? Okay. So we also want a pole roughly down here and a pole roughly up here, right? So I'm just going to try and think a little bit about how we're going to get that in. That one, I believe, is going to want to continue all the way around. We've got that visor one. Yeah, yep. So I'm going to continue this around because if we were to do an extrusion like this, right? If we were to say, well, it sort of makes sense that this should just extrude out here. It's going to place a pole here. By continuing this loop all the way around like that, we avoid that loop there, that pole, sorry, because we just turn this 1, 2, 3, and then a fourth, right? 1, 2, 3, 4 into a natural grid, right? So I'm just going to do that here. And then I'm going to grab all these edges and just extrude them up a bit, all right? Whoops. But this is in general the process of like how we would retopologize a more organic shape, right? We start laying down, like once we've got our sculpt sort of done and we have like a high poly to work from, we would start laying down topology that lives on top of it, right? Might add another loop there just to give us some more geometry. Drag that down a touch. Okay, cool. So this is like going to start being readily animatable, right? There's some, like the way that this kind of comes down here and then kind of dips down and then comes back, we'll massage that into place, but the basic idea is we're looking for this like structure. From here to here, this is going to allow animation systems to, like if I turn on, proportional editing, this geometry from here to here is going to allow these sort of muscles to get pulled up that way, right? These like lines from here to here are going to allow that laugh line to sort of pinch up and down like that, right? These lines from here to here and here and here are going to allow like the nose to kind of come up and crinkle and for the brows to come down and furrow, right? That's sort of what we're trying to achieve here, you know? Let me think for a second. So we have this pole here. And something that I like to think about is that this pole, this one here on the cheekbone, is actually going to connect to a few other ones quite readily, right? So we have this one's running up to the top, and then we want this one here, this underlying sort of bottom set, to run this way and around with that blue line, sort of as we've shown it, right? So this is going to be laying in one pole, and we're going to get almost like a second pole on the same line, right? We're going to get a couple poles here, which are going to be very interesting, and I'll try and get them in without issue. Oops. Yes. So we'll have one pole there. So by doing this extrusion, it's very hard to communicate directly, but kind of think of it like this, right? The only way to prevent a pole being made is to continue the loop extruding. Like each time I do this, I'm not making new poles in this loop, right? But eventually this gets so big and ridiculous that we can't continue, right? Every time that I do an extrusion and I don't continue the loop from, like, let's say if I grab these, so I want a pole here and I want a pole here, or maybe it might be like here more, I guess. Yeah, probably about here, right? If I do the extrusion like this, that means that this geometry is probably going to end up sort of extruding down, and we naturally have a pole here, right? Do you sort of see how that works? So that's kind of like the telltale sign, is that if you don't continue the selection along the entire boundary of the loop, well then by definition you're going to insert a pole there, right? So we want a pole here, like roughly down here, I guess, where like, because this lets us route, we don't want to continue routing like all of the geometry of the neck all the way up and around into the head. That would be the, like, we would have to follow the loop all the way around to prevent extra poles. This sort of gives us the option of routing this geometry like over here. And I won't do too much of like the neck and the surrounding area because I just want to really show the technique here that we're using. It really, again, hinges on like the snapping and, you know, your shrink wrap if you're not using snapping, but using these two like side by side actually helps, right? Let me line this up a little bit with the center line of the face. Cool. Oops, sorry. Shift these up a little bit so we have just slightly less discrepancy up there. Awesome. Okay, and then we have our loop that we've set here. This one here is going to be that sort of framing loop that's going to run the whole way around. So I'm going to try and just add a little bit more geometry here, so we got a little bit more to work with, a little bit more geometry up here, so our crow's feet just have a bit more to play with there. Basically, we want one pole here, and because this is a pole, right, like, it's not a pole yet, but if I was to do this, now it's a pole. We know that there's going to be a pole in this area, so that tells us, well, we wouldn't merge this face like this, because now it's not a pole, it's just a part of a grid. So we know that this framing loop is going to run sort of all the way up the side of the head, and if he didn't have hair, this would typically be like a bald person, or like, not a bald person, but a bald model, right? We would add the hair on later. This would be roughly at like the side of the temple, right? So I'll leave that edge down here, just for demonstration's sake. We now know that this geometry here, like this edge, needs to start merging in with these, but we of course need to match the edge count. We need 1, 2, 3, okay? So I'll run an edge loop and click here, and an edge loop and click there. So now we can make a bridge there, and a bridge there, and a bridge there, right? And we've done it that way because that gives us this pole down here, right? It gives us our little sort of magical pole. This structure on this side is actually really awesome to remember, and I'll point out why. It's very regular and has an easy little tip to kind of help remember it, okay? This is the pole here under the eye. Then it connects by a loop down to this pole on the jaw, right? Do you see how we just naturally have a loop? It's connected. We then end up connecting straight down to the pole where the jaw meets the neck. So we know, like, for instance, if you had your pole, I'm just going to cut some really bad geometry in here. Just sort of ignore the surrounding territory. I'm just going to try and make a point. If you had your pole here and it was offset like this, right? See how this line goes up into the eyeball? It doesn't necessarily match up with this pole here. That would be kind of like a telltale sign that maybe you haven't laid it in like super perfectly, right? So that's a really nice attribute of this pole and this pole, is that they just naturally link together. Same thing is true of this pole and the southern pole. The same thing is also true of this pole up here. So we actually end up with this structure that looks like this. Let me turn off snapping to just demonstrate that real quick. And my shrink wrap. We have a pole at the top of the temple, which is going to be this one. We have this pole here, which is going to be that one. We then have a pole down here, which is going to be this one. And then we have this pole moving up to like the corner of the eye here. So we actually end up with this connecting almost like Y structure. So this is a really like helpful sort of mnemonic for these poles. And then eventually, right, they're going to get subdivided a lot. So something like this is what the edges are actually going to look like, but we'll have one pole here, 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 and here, and they're all connected, right? That's kind of how I like to think about this one down here, except that it doesn't connect, is kind of the way I like to think about this. This pole routes down just straight into the lips, and then this pole's actually offset by 1 and routes straight up into the eye, right? That's kind of like how I think about it in my head, I guess. Cool. So now we can just make like some sort of adjustments to better, I guess, position. Oh, let me turn my snapping back on, sorry. To better position our loops so that we start getting like more, I guess, more even like quads, I guess. Like, they're never going to be perfectly even, but we want them like kind of even-ish, you know? Now, I said there's going to be a pole up here, so we may as well make that one. I'm just going to extrude up here into his hair. You typically wouldn't do it like this. I should have picked, you know, sort of a balding so not a balding model, but someone who didn't have hair currently that could be then added on later. And I'm going to establish this pole here, right? And now I'm going to sort of just bring this into the hairline, because again, there's going to be no poles, which means that this edge needs to naturally come the whole way up, and then we just bridge in. Okay. So now I'm going to use this sculpt brush to just sort of like massage these points a bit. And if I have the shrink wrap on, then that means that it's going to, even though the sculpt is not staying on the surface, it's going to be placed on the surface, right? Like if I turn the modifier on and I hit G and grab and pull over here, if I turn the shrink wrap off, this is what I've actually done. I've actually done that, and then it gets smushed back like onto the object. So it just helps us like keep everything glued to the face while we're in sort of sculpt mode to just sort of massage points around, right? Another thing that you can do is you can turn on, if we go to the object properties here, we go viewport display, flag wireframe. That's just going to let us see the actual wires of the underlying mesh. And that's really what I'm after here, because I want to just, I guess, smooth out the overall shape so that it's much more flowy, especially along those like poles and loops that we've sort of declared before. Like, do you see how these three kind of bunch up here and pinch, and then there's like a little bit of a gap here? We sort of want to ease that out, right? We want to do this like as I guess, eased and smoothed as we can, right? It's never going to be exactly perfect, and if we need it to be more dense, we can always like add extra geometry here. But I'm just going to move these down a touch. And then I'm holding shift and left clicking to like smooth those out. Cool. I'm now going to adjust these here. It's probably about time we actually lay the mouth in properly, right? Now this is going to get a little bit interesting because, I mean, David's mouth is closed, but we need to think about this in terms of like a mouth that could eventually open, right? The long and the short of it is, these loops on the top of the lips are naturally going to have sort of companions on the bottom of the lip, right? Does that make sense? So this one here is naturally going to like loop to there, right? This one here is naturally going to loop to here. And you can sort of see where this issue is going to start to arise, right? These are kind of offset, which is sort of a telltale sign that instead of just looping straight across like that, maybe I need another loop here, which is going to allow me to sort of keep them more in line. But crucially, it's not just them being in line physically, it's more about them being in line in terms of the loops, right? In terms of the overall geometry like this, right? So we need the loops to be in line like this, right? So if I was to merge that into here, if I was just to bridge from here to here, and we look at the resulting loop, we get a loop that runs down the neck, up into the mouth, and then up into the eye, right? That's not, you know, the worst like loop ever. I'm not like the greatest facial topology guru ever. Other people could probably comment better, but I think that's going to be fine. We'll leave that there. And then I'll cut a loop here. Oops, sorry. I'll bridge from here to here. That gives us this loop here. So it's sort of like I've merged that blue line into that yellow line and kept them as one, right? Do you see how I've got that here like this? That allows us to then, if we ever want to like subdivide the brows, we're also like giving us more, I guess, geometry in this area to like, I guess, snarl with and like grimace, you know? And then last, we need this like face here established, right? And that's going to do kind of much more of the same. It's sort of keeping the forehead looping out, and then gives us like, if you think of smiling really tightly with your mouth, you're going to use all this geometry and this loop to pull all of this up and in this direction. It's going to allow you to crease this way, and it's going to allow you to crease sort of this way, right? So that's kind of the point of like the topology, right? And then we can shrink that one down here. Now these don't actually look like lips, right? But at this point, we just want to kind of keep our topology, like that we want to keep these loops, I guess. If I just run an inset here that doesn't use boundary, because we don't want this loop here, because in the real world the lips would be fully filled out, right? So if I run an inset here, turn off inset, go down to inset faces and untick boundary, I'm just going to scale this in a little bit and start manipulating these verts so that they better match the face. And then I'm going to talk about sort of what we've done by doing this, right? it's sort of another way of allowing us to establish that loop for the inner lip, right? But crucially, by running an inset, by running an inset, we haven't disrupted the way that we've linked these loops together, right? We still have the loop going around, we still have the loops going up and through, and we still have like these loops linking out from the forehead out and all the way through. And we can run as many insets as we want doing this, because an inset is functionally the same as running a loop, like this, right? It only starts to behave a little bit differently when we start running insets on the inside. Sorry, loop cuts on the inside like this. But while we're running them on the outside at sort of the boundary of this structure, then it's just going to sort of centralize topology in this area. Now you can imagine that what we actually want to do is pull this loop very tight all the way in to the crease of the lips, right? Like this, all the way in. And then we want to add as much geometry as is required to depict the lips, okay? Like this, right? I'll run the loop that way. Now, when you're running loop cuts as well, if your camera is like at an angle and you loop cut, it's dependent upon the view, like this. So I'm panning my camera to a view that I know is going to project well, and then I'm going to loop cut and then left click just in place. So that's giving us the geometry that we actually need to depict these lips like accurately, right? And we can always massage and like move verts together. Now, what do we do about the inside of the mouth, right? If this was a standard model that had a more open like interior, let me just duplicate and apply my shrink wrap. And then I'm going to turn this one off so I can hide it, and I'm going to isolate it. What we would expect is for there to actually be an interior of this mouth, right? Like you should be able to open these lips up, but we want to make sure that, I guess, the interior is still adhering to our topology. And it's not so much that we want the interior of the mouth to have great topology, although that would matter if this was in like VFX or something and the character's mouth had to open and show the character the ridge of their mouth for some reason, right? It's mainly just to ensure that our loops remain all like kind of connected to each other and freely like subdividable. So as long as we run an extrusion back and then loop cuts, we can start to open up and give this mouth like actual volume, even though we don't really need it in this context, I guess you could say, right? Oh, sorry, I've been doing these loops with snapping on, so we'll turn that off. Now we'll scale it up. I'm just going to turn off that Retopology shader because it's getting kind of messing me up a little bit. And we don't want any like interior faces like this, right? Which we wouldn't get in a typical model if we had symmetry and all that sort of thing, right? So running loops like this basically lets us sort of open that mouth up internally on the inside and give us enough geometry to support like the internal mouth structure. But we're not actually going to do that for this. I just wanted to sort of show you how all we've done is we just extruded back and then we ran edge loops, and that actually keeps all of our loops and everything still together, right? Like if I select this one here, you can see that that loop is now continuing along the inside of the mouth and then back out. And provided that I keep sort of loop cutting or extruding, it's going to keep that structure. And the extrusion in particular has to encompass this last loop at the very least. It has to. And so extruding that loop is sort of, provided I actually select everything, is fundamentally sort of the same as running a control loop, provided that you don't allow these like internal faces to exist. Like those ones need to go. When we do that extrusion command, it's going to leave these here, and we've got to get rid of those. All right. But I'm actually going to delete pretty much all of this because our high poly is solid. It doesn't actually have the inside of a mouth, which means, you know, none of that's going to actually connect properly. So what I'm going to do is just bridge these all together and sort of just move them into the middle of the mouth and call it a day, right? Into the middle of the lips. Cool. Let me shrink that one over here. And this topology reference, by the way, provided that I haven't butchered it in my demo, is actually from an artist called Tom Parkin. I think Tom Parkin? Tom Parker, sorry. He's a principal character artist, done a bunch of Warhammer stuff. He's been doing it for years, and he's incredibly good, right? So this is essentially his topological layout, and hopefully I've recreated it, you know, pretty faithfully. If you get a chance, you should definitely check out his work. All right. I'm going to turn my shrink wrap back on. I'm going to turn my sculpture back on, and now I'm going to use my sculpt brush to sort of like, I guess, smooth these into position. Something like that. Maybe I won't use the sculpt brush to do it because we're starting to get pretty particular. But basically, I just sort of want to hint at, or otherwise imply, sorry, that hey, we could be handling the mouth interior if it had one, right? We don't just want to sort of cheat and throw n-gons in here, like we're here for our own educational benefit. So just giving it the topology that it sort of needs is going to be perfect, right? Something like that, okay? So now we have this really clean face structure, right? Like, do you see how quick I was able to just add more detail? Just bang and bang. And like, it's obviously view dependent, but in general, you know, add a couple extra loops, add another loop up to the laugh line, and then I can switch into my sculpt brush, move these around, smooth them back a bit. And this is sort of why your topology really matters, right? Or it's one of the reasons why. It can speed up your modeling process pretty significantly. In this context, it's almost certainly mostly because we need the geometry there for sculpting and animation. Animation in particular is going to be the big one for this sort of subject matter, right? Okay, so that's essentially like the human, I guess the human like face. We would do the same thing as we did with the mouth, but for the eyes, right? We would find ways to route loops that make sense. So let me actually, sorry, before I get ahead of myself, I'll probably come down here and finish the nose. I'm going to continue this loop here, all the way down and underneath the nose. But we know that I'm not going to introduce another pole in this area because I have one here. So I'm going to sort of do that. The nose as well almost always trips me up. So I don't mean to show you this nose topology as like an authoritative source on the matter. It always trips me up every single time. So let me just think for a second. I have, yeah, I have a loop underneath the nose where the nostril connects to the upper lip. This line here, and I'm routing that all the way up into the eye, right? I now actually want another loop. Let me think for a second, sorry. I have this loop under the eye. I kind of want that to land about here because we want this like nasal structure, I guess you could say. I've got my pole here for the nose. That links directly to the nasal fold. But maybe I don't want that there. Maybe I actually want a gap. Let me think, sorry. Yeah, I think I might have left that pole just a touch high. So I'm going to try and bring that down. Like physically move it down. But then essentially introduce another loop cut here. Oops, let me clear that before I accidentally click on the wrong one. And if you're going to be loop cutting like this with the knife tool, you have to make very sure that you're actually clicking the edge. Right, that's what I want to do. And then I'm going to try and shift the pole up and over. Yeah. Okay. So now I have that loop running up that way. Yep. Okay. So I've basically, what I've done there is I shifted it. The pole used to be contacting with this loop. By essentially running another loop on top of my pole, it allows me to shift it down, right? I'll try and show that again, actually. I'll communicate that again. So this is the ring that connects the two. If I dissolve that, I have pushed the pole, which is here, onto this nasal fold, right? But if I run a cut, basically what I want to do is I want to run a cut in the laugh line topology that's higher than the pole. I don't want to be below it. I want to be higher, right? Something like this. Making very sure that I don't accidentally click the face when I do this knife cut. I'm only clicking the edge, right? That kind of inserts another ring in here and pushes it up so that I can then put a cut there. Whoops. And I can turn that into the pole now. Oops, sorry. We want this one into the pole. Like that. There we go. So like it's, you know, even if you have experience doing it, topology can be actually like really tough, right? So that's why just try and consult charts for now, and like you'll learn it over time, right? It is a skill that you do need to foster. And I do, you know, I'm not the greatest character artist in the world, so just keep that with a grain of salt. Keep that in mind. I'm also going to add another loop here to give us more geometry. There. And now we have to start routing the nose. Now, I kind of cheat a little bit and try and just get the nose over and done with as quick as I can in a way that I find like decent. But that's because I'm actually not that good at it, right? But basically what we want is we want sort of a loop here on the inside of the nostril, and then we probably want a loop to come out and continue sort of around and down the nostril, or around and up to the nose. The way that I tend to do this is something like this. So I'll do like a loop that goes around like this, matching these loop counts like this to this. I'll have that, and then I'll have this come down like this. That's not actually in line with Tom Parker's diagram, so I'm going to try and put myself out of my comfort zone a little bit here, and I'm going to try and more faithfully recreate that diagram if I can internalize it, I guess, a little bit more accurately, right? So we go from here to here, and then we actually introduce a pole as this comes down like this. And you can sort of imagine that if the nose was going to snarl up like this, then we sort of need like edge loops in here to do this, right? Let me turn that retopologization shading back on. Lets me put these verts right in there. We basically need geometry here to support this, to allow for this to actually be formed, right? And because it's a loop, right, loops around into the middle of the nose, we can freely add, you know, more subdivisions to get more geometry here if we need it, right? Okay. Something like that. Now we can essentially continue this over to here. But, you know, we would want to actually merge these. Merge at center, 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 right? Now the funny thing is, I guess because that loop routes down, it's going to point straight down into the mouth and neck. So if we need more geometry here, we can run a loop like that, and it's going to send the geometry straight down here, sort of into the nose like this. Which means that we may need some corresponding extra loops down here to accept the loops that are going to come down from this nose, right? But we'll see. Like I said, I'm not the best at doing nose retopology, so I'm just going to add a couple loops up here just to get the shape sort of going there. And then we want probably for maybe, I might collapse this edge maybe, or get rid of this one perhaps. Yeah, I'll clear that one because I don't want too many loops in here, and it's okay to clear this because we can always sort of like add more geometry back once we establish our topology. I essentially want this to go from here to here, but to actually, you know, have these middle loops as well. So I'm going to do an extrusion like that. And one, like, I kind of want to do this like this. Right? But there might be too much geometry in here, so it might actually be beneficial to just get rid of one of them for now. And then I want to go from here to here. Okay, so that's sort of, I'm keeping the mouth and the front sort of in line, right? And then we've got this one. It sort of makes sense to me that maybe this routes down like so. I might actually get rid of this loop then to make that a little bit easier. See, sometimes like less is more. Having like less geometry actually can make this a lot more tolerable. I might add a loop cut here. Careful though if we're using snapping, because it's going to muck up maybe that internal. So I'll turn off snapping here and then turn it back on. I might want something more like this. Yeah, I find noses incredibly difficult to finalize this off. That one there you sort of get for free, I guess. And then I suppose we have that there. Yeah, this is where it's going to get a little annoying. If we try and think axiomatically, this makes sense. But there's just too much geometry on top, you know, so maybe get rid of that, move this back. Run a loop here to accept this one. Whoops. Gives us a little bit more geometry up here on the nose. See, that routes it around that way. And then routes that one around in this way. That one routes down. Yeah, it really is quite difficult for the nose in general. At least the way I see it. I've never been good at them. And problem solving is going to be a large part of this anyway, so I'm just going to spend some time to try and actually solve this one. Whoops. Might even make sense to sort of collapse that ring. That kind of frees up that problem just a touch. Add another loop there. If we get rid of that one, now we're starting to match like the edge count. So I'll do that there. And I'll try one more here like this. Loop and loop. Okay. So now I'm going to check the loops to see if they sort of make like any sense, you know. Okay, loops around, continues around. Okay. But now I've got to deal with this mess that I've made here, right? Because that's kind of the danger of just running control loops. But if I duplicate that and apply that real quick, because the topology is roughly laid in pretty decent, it sort of becomes quite easy, right, to just sort of smooth this back out. Right, it's almost kind of like magic, I guess, right? Okay. Now we actually need to do the nostril, but we're kind of probably just going to get that for free by running an inset, you know, or running a few insets. Maybe to there. I'm going to actually turn snapping off for this one because it's going to be such a large distance. And let me turn off shrink wrap as well. So I've done my inset, and then I'm going to inset again, right? And I'm going to really shrink this down and start organizing my verts so there's not such kind of gross geometry. And then just try and get that up, way up in there with that nose right there, right? Run another loop. And then now I'm going to turn my face snapping back on and start organizing these sort of one by one, right? Now again, I've probably almost certainly like butchered the actual topology, but it is at this point that I would probably run over to an animator and see what they thought and then get their opinions and ask them if this would be appropriate for their needs, right? And then just base my decisions based upon what they say. I'm going to roughly leave that there. Turn back on my shrink wrap. And just, we're looking now for like areas of major discrepancy, right? So we need another loop here around the lips, or to at least, you know, reposition the loops. The reason they jump like that is because their true position is actually quite far off. And that's why you'll notice that I will often duplicate and then reapply the shrink wrap. Because it's going to force its true positions to now be like on the surface, or where it was projecting to, and it's going to be a lot easier to move. Okay. So this is, I guess we may as well call it there rather than just sort of fiddling with the nose all day, but there's some extra things we can do here as well, right? So if I put on a subdivision modifier, I can subdivide this up, which smooths it, and then I can re-shrink wrap back, like to the head, right? And say we want to be above the surface by like 2 millimeters or so. And you can see how the subdivision modifier is just naturally going to place all of the geometry mostly where we need it. It's kind of like, and then project back, I guess you could say, right? We can now massage with our like sculpt brushes to get the topology roughly where we need it. And then when we're ready, we could apply these modifiers down and just get like exactly the verts where we exactly want them, right? And because we've got the loops all laid in, like I'm noticing here, there's not really enough geometry to capture the eyebrows. I can just run another edge loop, right? And then massage around. Whoops. But in an ideal world, the character wouldn't actually have hair, you know, baked into their skin. We would sort of do that a little bit differently. Okay. Right. And in general, like not the greatest topology in the world, but pretty damn solid, right? Like we have really good support for like expression around the mouth, like arguably maybe even a little bit much, right? Like if we compare it to the cheek and stuff, we could probably collapse some of these edges and reduce a little bit of that. If I grab this and let the subdivision modifier really bring in the geometry that we need there, right? Yeah. So this is this is sort of the process by which things are retopologized, right? It's very manual, can be a bit laborious, but you know, it's something that you will have to roughly learn, right? Okay, cool. I'm going to leave it there.